Hello and welcome to Physics Tips for Cambridge Students YouTube channel. Today we are going to be looking at the topic of work, energy and power, which is in the 9702 AS syllabus. This video is going to cover two concepts on the syllabus, that is energy transfer and conservation, as well as work and efficiency. In my second video, I will be talking about kinetic energy and potential energy, as well as power. Remember to subscribe to the Physics Tips for Cambridge Students YouTube channel and like, share, comment, and as well as hitting the notification bell so that you get alerted of my future videos. Without much further ado, let's get started. Lesson outcomes. My aim is just to combine the outcomes and deal with them at once. So my notes are in such a way that they are all covered at once. I also am going to assume that you have already covered the IGCSE or the O-level physics on the forms of energy and energy transfers. So the syllabus assumes that you have already covered the IGCSE or O-level physics, that is forms of energy and energy transfers, but I am going to look at those concepts again. It is just a form of recapping energy transfer and conservation. So energy and work are linked together. When you do work on a body, it gains energy and you lose an amount of energy equal to the work done. So the amount of energy transferred is equal to the work done. And energy is defined as the capacity of a body to do work. Different forms of energy include gravitational potential energy, kinetic energy, electrical potential energy, elastic potential energy. So these are covered in depth in the IGCSE syllabus. If energy is lost by an object when it does work, it is gained by another. This is called the principle of conservation of energy. The principle of conservation of energy states that energy is neither created nor destroyed, but it changes form without any change in its total amount. The concept of work and efficiency. As I've said earlier on, work is defined as the force multiplied by the distance moved in the direction of the force. Now, if you've got a force that is acting at an angle theta to the horizontal in the direction of motion, shown by the distance s there, you need to resolve the force so that it is in the horizontal as well. So you get F cos theta and multiply by the distance that is going to be moved. And it's going to be F cos theta s. Now, work itself is a scalar quantity, although force and displacement are vector quantities. The unit of work is the joule. 1 joule of work is done by a constant force of 1 Newton on an object when the object moves 1 meter in the direction of the force. No work is done if the displacement and the force are at right angles to each other, and also no work is done if the object is moving at a constant velocity. So in other words, when the kinetic energy is constant, there is no work that is done. Now, if you plot a graph of force versus displacement for a moving object, the area under the graph depicts the work that is done. Work can be positive or negative, as shown in the example here, that the, the distance moved is 5 meters to the right. The force that is being applied is 10 newtons at 30 degrees to the right as well. The object has to speed up. So if you resolve that, 10 cos 30 times 5, it's going to give you 43 joules, and it's going to be positive work because both the distance and the force are in the same direction. Now, negative work is done when the force has a resolved component in the opposite direction to the displacement. As you can see here, 10 newtons to the left at an angle of 30, and then the distance is 5 meters, but then in the opposite direction. So in other words, we're saying that this object is slowing down. In this case, 10 cos 30 times 5 would be negative 43 joules. No work is done, like I said earlier on, if the object is moving at a constant speed and the kinetic energy remains constant. Now let's look at this example. A horse is pulling a barge along a canal as shown in the diagram. It pulls the barge with a force of 1000 newtons at a distance of 75 meters. Angle the rope is that it makes is 15 degrees in the direction of travel. The situation is as shown here. So we've got the 15 degrees in between and the forces at 1000 newtons that way. The first question says, can you explain why the work done is not 75,000 joules? The line of action of the force is not in the same direction as the movement. We need the horizontal or the forward component of the force. So that is why it is not 75,000. You really have to resolve here. Now, part B says, what is the work done by the horse? Now, to find the work done by the horse, you need to resolve first the force, like I said. So it's going to be work done is equal to force times distance s, which is going to be 1000 cos 15 multiplied by the distance, 75 meters. So that's going to give you a value of 72,400 joules. Efficiency. Machines waste some of the energy supplied to them due to friction in the moving parts and heat of thermodynamic losses. Sankey diagrams, which you've already covered in the IGCSE syllabus, they tend to give a visual illustration of an output-input situation. Now, just to recap what you did at IGCSE, we have 1000 joules of chemical energy put in this system. 150 joules are going to be lost through the exhaust, and then we have 850 joules as movement energy in the engine. But then of this 850, 550 joules is going to be wasted in the moving of all the parts of the engine, and only 300 joules is going to be useful energy to move the car. So to find the efficiency here, we're going to say the useful energy output over the total energy input. So that's going to be 300 joules over the 1000 times 100. So that will be the efficiency in this case. Let's look at an example to further cement this. An electric winch takes 500 amps from a 12-volt source. It is 25% efficient. What is the useful power? Now, this is in terms of the power, so you need to write down the formula first. So efficiency is equal to the power output, that's the useful power output over the power input, times 100. Now, in this case, you have been given the efficiency, so that's going to be 0.25 is equal to the power output, which we want to find, over the input power, which is the 500 times 12. Remember, power is equal to voltage times current. So to make the power output the subject of the formula, you just multiply all those. So it's going to give you 500 times 12 multiplied by 0.25. That's 6000 times 0.25, which is going to give 1500 watts. I'm going to end the video here and continue with the concept of potential and kinetic energy in the next video. Please remember to subscribe to the channel and like, share, and comment. Signing out.